In this video, you will learn about rotations. Now, first off, we need to define our terms. What is a rotation? Well, a rotation is simply the turning of an object. So think of a wheel. Okay, a wheel turns or rotates. And with a rotation, you can change both the location and position of an object. So again, with the wheel, okay, it rotates, but it's also moving. All right, that's kind of maybe a basic idea of rotation, but we can change the location and position. And with the rotation, the figure can move either clockwise or counterclockwise around a point a particular amount. So clockwise would be positive, that's your positive measurements, and clockwise would be negative. So counterclockwise is positive, clockwise would be negative. And with a rotation, this would be in isometry because we are preserving measurement. Okay, the size of the shape is not changing, it's simply being moved in space. When dealing with rotations, we also have notation to be aware of. So here we have the picture of a wheel. Okay, where in this wheel, O is the center. When you write this in notation, okay, notice what we have. All right, so we have a fancy letter R. So if you were to write this freehand, I personally write it like this. You can maybe do something different. So that's going to be your rotation letter because we have to clarify with the R because we have rotation and we have reflections now. So reflection is just a regular R. Rotation is going to be more of a fancy R. And then we have here as subscript two different things. So we first have the center point. So letter O, that's going to be your center point. All right, and then comma, and then what comes next is the degree or amount of rotation. So that would be 90-degree rotation. So those are both subscript, meaning they're smaller and kind of beneath the regular size letters. So that is the name of the transformation, okay, this rotation with a subscript of 0, 90. And then we have a colon, and then it shows what maps to what other point. So here we're mapping point C to some other point. And the question is going to be, what point does point C map to? And as we mentioned, O is the rotation point. That is the center. So if O is the center, and we're looking at point C right here, and it's being rotated 90 degrees. So 90 degrees would be this direction. This is the positive direction. So here, if we go to point B, notice the angle created is 45 degrees. So we need to keep going beyond that to get over here to point A so that we have a 90-degree angle created from the center to point C and up to the other point up here. So point C would map up to point A when rotated 90 degrees about the center point O. Let's try a few more examples like this and see if you can get to the answers before I get to it here in the video. So next we have a rotation with the center point of O going negative 90 degrees, and we're trying to map point C to some other point. So again, we're starting with point C, which is right here, this point, and now we're going negative 90 degrees. So if you imagine this segment right here to point C from the center, we're going 90 degrees this way. That's the negative direction. It's clockwise. We're trying to create a 90-degree angle with that segment from the center to point C. That's going to take you down to here. This would take you to a 90-degree angle, which means point C would go down here when rotated 90 degrees. It would go down here to point E. So E is the answer to that one. Okay, let's try another one. Here we have the rotation with the center point O of 45 degrees. And we're mapping point H to some other point. So in this case, we're starting with point H right here. And to do this, we can draw a segment to the center from point H. And we're rotating point H 45 degrees. So it's going to be this direction. That's the positive direction. And we want to create an angle such that we have a 45 degree from, or using HO as one of our sides. So if we go down here to this segment, okay, this would be a 45 degree angle, right? It's half of the 90. So if we go 45 degrees from point H, that would take you down to here to point G, because that gives us that 45 degree angle. Let's try another example. Here we have the letter H. Okay, this is different because this letter H means a half turn. And actually, sorry, we shouldn't even have this 180 here. The H indicates that it's a rotation of 180 degrees. So we don't need to actually write the 180 in here because it's assumed that you know what the letter H means. H means half turn. All right, so that would be the same thing as saying R, so fancy R, sub O of 180. That'd be the same thing as HO. Okay, that's the same thing. All right, so define this. Okay, we look at point 8 or point E right here, and we're trying to rotate this 180 degrees. So to make that happen, okay, you can imagine a segment being drawn from point O to point E. So rotating in 180 degrees, we'd have to go all the way over here to point A. Because when you do that and you draw a segment from O to A, notice we've created a 180 degree angle. So it goes to the opposite side of this circle, which takes you across to point A. So the half turn of point E about the center, point O, would be to point A. Let's try one more. Here we have the rotation with O as your center of negative 135, and we're mapping F to some other point. So we're starting here with F. We're going in the negative direction, which would be this direction. Okay, and we're trying to make a 135 degree angle if you look at FO as one side. So to point G, that takes you to 45 degrees. Point H, that's 90 degrees. Point A, that's going to be 135. Right, we go by 45 degrees, 45, 90, 135. That takes you over here to point A. That would create a 135 degree angle. So point F would map over here to point A. All right, so that would be your solution to that one. It's going to be point A. And we actually have one more on this slide. So last one right here, we have point D, which is this point, and we're rotating 360 degrees. So it doesn't matter where your center point is or even which point we start with. If anything is being rotated 360 degrees, a circle has 360 degrees, which means it's going to go right back to where it started. So point D would go right back here to point D. All right, so rotation of 360 degrees takes you right back to where you started. Now with circles and with any rotation, okay, we can go further than 360 degrees. So make sure that we also know how to write equivalent degree measures. So if it's like 720 degrees or 500 degrees, okay, it's going to go back around to another location on the circle. So here we see an example of that. All right, so what we're doing is we're rotating, okay, this point right here, we're rotating 400 degrees around the circle. Well, we want to figure out what is this equal to. Can we simplify this a little bit? Well, if we go one time around, okay, all the way around, that takes you to 360 degrees, right? Now for a 400 degree rotation, we have to go beyond that an extra 40 degrees. So what we do is we can write that as 40 degrees. A rotation of 400 degrees would be the same thing as a rotation of 40 degrees because we just do 400 minus 360 to get our equivalent measurement. Now what about a rotation of 660 degrees? So again, 360 will take you all the way around back to the original point. So if we subtract 660 minus 360, that would give you 300. So a rotation of 660 degrees would be the same thing as a rotation of 300 degrees. So I would start here and go around probably to about somewhere around here maybe. So it would be from there all the way around to this location. So that's the same thing as 660 degree rotation. Now what about a negative degree? What about negative 30? So negative 30 degrees, we can write this with a positive degree measurement, because if we start here, we rotate this way 30 degrees, that'll take us maybe somewhere around here. Now we could go the other way. We could go this direction and get the same answer, the same final destination. So what we can do is we can do 360 minus 30 to get that equivalent rotation. So 360 minus 30 would be 330. So that would be the same thing as a rotation of a positive 330 degrees. All right, so those are equivalent rotations. What about this one? We have a rotation of negative 240 degrees. So again, same idea. We can do 360 minus 240. That would give you 120. So that would take you somewhere around here. So rotation of negative 240 would be the same thing as a positive 120 degrees. Okay, here's another one, rotation of 45 degrees. So we could, if we wanted to, we could write positive degrees with negative degrees as well. So we wouldn't do this as often as the other way around, but we could if we wanted to. So what we can do is we could subtract by 360. Right, so 45 degrees would take you up to about here, right? But if we go the other direction, if we go this way, so we do 45 minus 360, that would give you a negative 315 degrees. And that would take you to the same final location. So make sure you can go back and forth between any of these. So if it's larger than 360, if it's negative, make sure you can go to positive. And if it's positive, make sure you know how to get into a negative number. Now to finish off, we want to actually rotate figures. So if you're given a shape, how can we rotate about or around a given point? So our first example is we have this picture, and we're trying to rotate this triangle 90 degrees around the center point O, where O is going to be the origin, which is this point right here. All right, so when you rotate, okay, this point right here, this vertex on the triangle, because it's right on the rotation point, the center point, we don't actually move it. All right, that vertex will stay there, okay? What needs to move is going to be this point right here and this vertex right here. Those 2 points we want to rotate 90 degrees. So if you're trying to sketch this out, what you want to do is, if we're trying to move this point, for example, you take the segment right here, this side, and create a 90 degree angle with it. So see here in red, we've created a 90 degree angle with that. Okay, make sure that it's 90 degrees, and then you can find the measurement from the center to this point, to the vertex, go that same distance up here to find where the point would go when you rotate it. All right, so we have this point right there is our second vertex, with the first vertex being right there on the rotation point. And then this third vertex over here, okay, same idea. We want to create a 90 degree angle with that segment. So see the segment here, create a 90 degree angle. And again, you want to keep the same distance, the same length. So the length from the center point down to this vertex, you want to have the same length from that center to this vertex up here. And so now we have our 3 vertices, the rotation point, and then these other 2 vertices up here. Connect the dots to get our rotated triangle. So this would be your picture. Now, by the way, if you're sketching this, you might struggle a little bit with getting the exact point. Okay, it might be slightly off. With 90-degree rotations, here's kind of a little trick of the trade that you can use. All right, so for this point, for example, if you're trying to figure out where that goes over here, this is kind of my personal method. So I see how far to the right does it go from the center. So it's over 1, 2, 3, 4, 5, 6, 7, 8. So it's over 8 and then up 1, 2, 3. Right, that point is 8, comma 3. What I can do is instead of over 8, up 3, I go up 8, over 3 to find this corresponding point. So from the center, I go up 8 to the left 3. That takes me right here. And that's how we got this point. Same thing for this point. If we go over 1, 2, 3, 4, 5, and up 1, 2, 3, 4, over 5, up 4, instead I'm going up 5, over 4, which takes you to this point right here. So this works with 90-degree rotations. You can use that technique. That was actually what I used to create this picture to make sure I had the correct points. I used that technique. All right, so let's try another one. Here we have a rotation of negative 90 degrees. And you still have the center here at the origin, which is right here. All right, so for negative 90 degrees, we're rotating back over here into the first quadrant, back to the right. So again, we're using the same logic to rotate. We have 3 vertices. So here, if we begin with this first vertex, you want to create a segment down to this origin, down to the center point, and then create a 90-degree angle with that. So see here, we have these 2 red dotted lines. We've created a 90-degree angle, and the distance from the center point to this vertex needs to be the same as from the center point to this vertex over here. And we find that point using that method. So we found one point. Let's do the same thing for the other vertices. So for this one right here, this vertex, okay, we create a segment to the center, and then we create a 90-degree angle with that. All right, so it's going to be up here. So the distance from the center to this vertex needs to be the same as from the center up to this vertex. And that takes you right here to the second point. And then lastly, we do that again with this third vertex right here. The distance from that to the center is right there. You see the red dotted line. You want to create a 90-degree angle with that segment. And that distance from the center to that vertex will be the same as from the center to the other vertex, which would be right here. So we have our 3 vertices. We connect the dots. And here we have our rotated triangle. And again, we could use that same method I mentioned before, where if this is your center, if you look at this vertex right here, it's to the left 1, up 3. So instead of over and up, over 1, up 3, we go up 1, over 3 to get to this point right here. That's the corresponding point, and that works with the 90-degree rotations. We do that for all the vertices, and we find that we'd have the same vertices right here that we have in that picture. All right, so that would be your rotation of negative 90 degrees. One more example. Here we have H sub O. What this means, remember, is a half turn. So it's a 180-degree rotation. And here is your picture. You're trying to rotate this 180 degrees around this as your center point. So when you do this, you can take each vertex. So you can begin with this one right here. We create a segment from the center to that vertex. And then because it's 180 degrees, I'm just going to keep going in that same direction beyond that center up to here, the same distance, and we get this point. All right, so that point would be corresponding with this vertex down here. Same thing again with our second vertex. So right here, we can find a segment from that vertex to the center, go the same distance beyond in the same direction to take us to this vertex right here. So now we have our 2 vertices. Do that one more time with the third vertex. We go from that vertex to the center, and then we go the same distance beyond it, which would take you to this vertex right here. All right, so then we can connect those 3 vertices, and we get this triangle right here. And now with a half turn like this, a shortcut we can use is that our point xy would be mapped to -x, -y. So for example, this point right here was 1, -1, 2, 3, 4, 5. So 1, -5. The corresponding vertex would be -1, +5. So -1, +5, that takes you right here. And that goes for each of these vertices. We can do that shortcut as well. And that concludes our lesson for today. We will see you next time.